day 5, we're going to just put all the things we know together. We're going to talk about the intercepts, the zeros, how can we graph it, those end behaviors, all that stuff. So even though we have this list up here, I am going to do the 5 things you see down here every time for my graph. So if you want to write that down, that's what we're going to do. Okay. So we're going to make a rough sketch of each of these. So let's take a look at step number 1. Step number 1 says to factor. Now, if it's factored, we're great. This is a monomial. There's no factoring involved. It is what it is, what it is. So we don't really have to do step 1. It's kind of done. To find the zeros, we're going to set that equal to 0. Well, if we divide 0 by 0, or if we divide 0 by -1, we get 0. If we take off the cube root 0, you still get 0. So we know we have a 0 or a intercept at 0. This is also our y-intercept. If our x-intercept is 0, so is our y-intercept. So the only place we hit the x-axis or the y-axis is at 0, 0. Now, if you recognize this is a parent function that has just been multiplied by -1 or flipped over, we know that it's going to take our cubic and flip it upside down. So the left end's going to go up and the right end's going to go down because our lead term is -x cubed. It's our only term. So we know some stuff about that parent function. So that leads us very easily to sketch it. So it's going to go up to the right and down to the left, those 3 nice points for a cubic. If you plug in -2, you do get +8. If you plug in +2, you do get -8. So if you're unsure, feel free to always plug in more points. So recognize that it looks a very similar curvature to a parabola, half of it going up, half of it going down, but it's just thinner and pulled apart. Yes. So we always know for a parent function cubic that we have that 0, 0, 1, 1, -1. -1 has been flipped. So in this case, -1 went up, 0 still at 0, +1 went down. It's a function. Feel free at any time to plug in some points if you're unsure of what the heck is happening. So number 1 is a pretty easy graph, hopefully, for you. Try to graph these at least to 3 points accuracy. Okay. Now let's move on to number 2. Now, the first thing I ask is that you get it into factored form. So the easiest thing you should always look for in factorization is, can you remove a greatest common factor? So you'll notice that they both contain an x. The lowest power is 2, so that means I can factor out 2 of those. If I divide both of those by x squared, I'm left with 2x minus 3. So once the factoring is done, just set that factored form equal to 0. That will help us find our x-intercepts or zeros or horizontal intercepts or whatever the heck you want to call them. So this allows us in factored form to split it apart. So where does x squared equal 0 or 2x minus 3 equals 0? Well, this is at 0. It does have a bounce or a multiplicity of 2. Okay, so don't forget that. Watch what happens to the 2x minus 3. It becomes 2x equals 3. So it does change that sign on the 3, but you do have to divide by 2. There is no bounce at 3/2. We're going to go through that point. So now we know the zeros. So the last kind of intercept we need is our y-intercept. Just plug in 0. If you plug in 0, you get 0. Remember, I said earlier, if your x-intercept is 0, 0, your y-intercept is also 0, 0. So that kind of makes sense. Now, before we go further, let's put on the intercepts that we know. Let's just stick them on the graph, okay? So we know we hit 0. We know we hit 3/2 or 1.5. Anytime it's a decimal value, just guesstimate for me. These are rough sketches. I don't need them to be anything super fancy. Okay. Now, you got to remember that we are going to bounce at 0. We are going to go through 1.5. But now let's talk about the ends. The ends can be found by looking at your lead term. Your highest power term is 2x cubed. 2x cubed would be down on the left and up on the right. So that's what we would expect the ends to do on this particular function. So go to your leftmost end and go down. Go to your rightmost 0 and go up. So go to your leftmost 0 and go down. Go to your rightmost 0 and go up. So the only thing that really we need is what's that connector? Because remember, a polynomial should be drawn without ever lifting your pencil. So we need some kind of bump. Now we need either, if we went through 0, it would be up here. But if we bounce at 0, we need a little like parabola shape there. So you could always plug in 1. 1 is a point between 0 and 1.5. So if you're unsure and you plug in 1, you do get -1. That is a way to verify that you do bounce downward. You don't have to plug in that point. You can plug in as many points or as few points as you have to, but we do bounce and come back up. So everything that we thought is through. We have a 0 at 0 and 1.5. We have a y-intercept of 0. Our left end's going down, our right end's going up. We bounced at 0 and went through 1.5. Okay. Everybody good with number 2? These are pretty great once we get used to them. The hardest one, I think, is one that is like number 3. Now, to factor one like this, we can do the trick we were doing yesterday. We could try to plug in some numbers and then remove a factor and then see what's left because it's a 4th power. But I am going to give you a little trick to factoring this you might have seen back in Algebra 2, or if you haven't, new trick. Okay. Do you see how our coefficients go? +1, +1, -4, -4, and there's 4 of them. Okay. When that happens, it's probably a technique called grouping. I don't know if you remember last year in Algebra 2, a technique of factoring called grouping. I taught Algebra 2 for a million trillion years, so I know lots of things to look for algebraically that I can help you with. So when factoring this, first off, let's take out the greatest common factor, and then we'll use grouping on what's left. We're left with x cubed plus x squared minus 4x minus 4. I'm going to write that actually over here so I have room under it. Okay. Now, there's a technique in algebra. If you see 4 terms, they're going in descending order, and there seems to be a pattern with your coefficients. So this one went 1, 1, -4, -4. It's probably going to factor using what's called as grouping. We're going to group these 2 together, and we're going to group these 2 together. We're going to pretend those 2 things individually are the only terms sitting there, and we're going to say, what is a greatest common factor? Okay. So I'm going to ignore this x for a moment. What I've underlined in blue has an x squared in common. And if I take out an x squared, I'm left with x plus 1. What I've underlined in green, they each have a -4 in common. If I take a -4 out of each, I'm left with an x plus 1. Now, I know that grouping is successful if the inner parenthesis, that x plus 1 matches. That means it's going to be something I can take out. So it means that this stuff is a factor that I can remove. It's a thing, it's a factor, it's a y, it's an x, it's an m, it's a thing. So I'm going to remove that stuff. When I remove that stuff, I am left with x squared minus 4. Okay, so it allows me to find a hidden gem, a hidden little factor. Okay, but you can, of course, do the technique we did yesterday. If you plugged in -1, you would find it's a 0. You could remove it. You'd get a cube. You got to do it again, blah, blah, blah. Okay, anyway. Does anybody see the pattern that we found with x squared minus 4? Anybody see that pattern? How can we factor that? How can we factor x squared minus 4? The other day I gave you a pattern that if you have the difference of squares, that is a plus b and a minus b. You can square root it with a plus and a minus between them. You have to know that formula. That's essential. So our final version of our factorization is x plus 1, x plus 2, x minus 2. Now, our lead term in the above polynomial was an x to the 4th. So the fact that we found 4 different factors is a really good sign, because that tells us that we have factored it fully. It's good to go. We're ready to go. So step 1 is a little harder for number 3, but that is how you factor that. So next we can move on to the zeros very easily, because if we set that equal to 0, we have 4 zeros. We have one at 0, -1, -2, and +2. So if we solve each one of those, this one's 0, -1, -2, and +2. Let's put those points on our graph. 0, -1, -2, +2. Okay. The only one we may not have, these have been given us a lot of 0 intercepts for the y-intercept, so that point's accounted for. Now let's talk about the ends. The ends always require that we know our lead term. Anytime our lead term is an even power, the ends act like a parabola. If our coefficient is positive, they're both pointing up. If our coefficient is negative, they're both pointing down. This coefficient is positive, so our ends are pointing up. So go on to your picture. Let's add that to it. From the leftmost 0, we have to go up, because we're never going to touch 0 again. From the rightmost 0, we got to go up. Okay. So now we've already kind of been doing the sketch as we go. Now, each one of these is unique. There's no powers on them. So we're going to go through. It's going to look like a W kind of, you know. If you want more accurate points, feel free to plug in some values in between there. I am not going to. I don't give a crap. I don't care how low those go, how high those go. Just make a bump, make a bump, make a bump. If you want to be more accurate, yeah, that's wonderful. But it's not necessary for where we're at in a pre-calc class. So it goes through, it goes through, it goes through, it goes through. Again, the heights of the bumps are something you would determine in a calculus class. The only way we could determine what the bumps are is we would have to plug in values. You can plug in values, I don't care, but not necessary. Okay. Okay, everybody good with number 3? Let's look at number 4. So the first thing we're going to do with number 4 is we are going to factor it. Always look for a greatest common factor. It has an x in it. The lowest power is 3, so that means I can remove an x cubed from both pieces. If I divide out an x cubed, I get x plus 1. Don't forget you have to have that 1 here. A way to check your work is if I redistribute, will I get what I started with? And you would. That gives us 3 zeros. X equals 0. Has a multiplicity, but it's odd. The multiplicity is a 3. So it doesn't do anything. It's still a through. A multiplicity only bounces if it's an even multiplicity. So 2, 4, 6, 8, or 10 as a power is okay, but 1, 3, 5, 7 doesn't do anything. Because if you plug in a negative, you're still going to get, it doesn't change it. This one has a 0 at -1. Its multiplicity is 1, so we go through that as well. So why not put those on at 0? We touch the graph and at -1. Okay, so now we've done the factors and the zeros. Those things kind of go together. I don't know why they've done this to us multiple times, but the y-intercept is 0. If it's another value, plug it in. Okay, plug in 0, see what you get. The 0 will not, or the y-intercept will not be 0 if you have a constant like a +3 or +2 on the end. That will change that. And then our last steps are the ends. Our lead term is x to the 4th. So both ends are going to go upward. So go to our graph and go like that. Because now we're ready to sketch it. So it looks very much like a parabola. It's just going to go down and connect it. I'm just verifying that I haven't lost my mind that that's what happens. But I believe everything connects. Sometimes it has a little wiggle in the middle, but I don't think this one does. Let me just check real quick. Yeah, it does have a little bit of a wiggle, but not much. That's kind of what it looks like. Okay, so so that is number 4. Again, my knowledge of calculus let me think that it's not a perfect little cup like a parabola, but you don't have to worry about that until you're sitting in a calculus class. Everybody good with our graphs that we see there? Okay. Now let's take a look at number 5. Now, for this particular one, grouping is not going to be helpful. So we have to use some tricks of the trade that we have been using up to this point. So the factored form for this one, I don't think grouping is going to help us. So just because of my knowledge, I would start plugging in possibilities. I would start looking at what's our possible zeros. Where does it possibly hit the x-axis? If you plug in numbers related to our, p's over q's are 8, I would plug in 1. If you plug in 1, you get, let me tell you, I think you get 1. Let me get a calculator to make sure. Yeah, you get 1. So that's out. So then I would try -1. If you try -1, you get, I think, a positive, pretty big positive number. Yeah, you get 27. That's out. If you plug in 2, you do get 0. So that means that hiding in there is a factor of x minus 2. So to get this one into factored form, we're only going to have to do it one time, but we should do synthetic division. So let's pull out our coefficients, -1, 6, -12, and 8. And let's make our synthetic division box. So my box is ready to go. We're going to multiply, write it down, add them up, multiply, write it down, add them up, multiply, write it down, add them up. I better get that zero remainder, which my remainder theorem told me would happen. Let's put our x's back in. So this would be negative x cubed. No, I'm sorry, it was a cube. It goes down to a squared plus 4x minus 4. Now, that is a factorable quantity. That might be a factorable quantity. Let's check to see if it is or if it is not. If I take out a negative 1, I just move that negative 1 in the front. It's easier to factor something where our highest power lead term is a positive. Oh, good. It does factor. Yay. That factors to be x minus 2 and x minus 2. So this does factor. Our original function had an x minus 2, a negative, and 2 more of those. So it is negative x minus 2 cubed. So what started out being disgusting looking, we ended up getting something that is just in a transformed parent function form. It is going to flip. It is going to have its center at 2, 0. Okay. So if you recognize that, great. We have factored it. The only 0 is at 2, so let's put that little dot on there. For the first time, if you plug in 0, you do get 8. So we can put that little dot on there if we want. The lead term is negative x cubed, which makes my left end go up and my right end go down. Always compare the power. If it's even, it acts like a parabola. If it's odd, it acts like a cubic. So if we sketch it, oh, look, the left end's going up. The right end's going down. It's a cubic that has been flipped and moved to the right 2, which is exactly what has happened. So that's why that factored form is so important. Anybody have any questions about number 5? Okay, let's move on to number 6. What's a way, anyone notice a way we can factor number 6 right off the bat? What's a way we can factor number 6 right off the bat? Always look for a greatest common factor. Is there a greatest common factor? Yeah, that x squared. So let's rewrite this in factored form to be x squared can be removed from each, leaving me x minus 2. So if we get it in factored form, check. When we set it equal to 0, it becomes much nicer form. Because x squared equals 0 at 0, but it does have a bounce because there was an original power of 2. X minus 2 equals 0 at 2. Nothing happens there. We just go through it like normal. Let's put those on, 0 and 2. The y-intercept for this one is 0. That always happens when you get to factor out an x. It always gives you that 0, 0. The ends are dependent upon our lead term, which is x cubed. The right end's going to go up. The left end's going to go down. Let's put those on. From the rightmost side, go up. From the leftmost side, go down. If you want to plug in points, go for it. I don't care. Now we got to make a bump, but where does our bump go? At 0, there should be a bounce. So that means that to form that little parabola shape, I have to bounce here and come back through. So if you wanted to verify, you could put in 1. If you do plug in 1, you do get negative 1. So there is a down and back through. So that is number 6. Do we have any questions about the graphing? Does that clear up some of the things that we're doing for the graph and the ends and the zeros and all that stuff as we put it all together? Okay. So for these problems, we're going to quickly talk about the end behavior. Okay. Just a little bit more practice on that concept. Let's just do these 3 odd ones since we're here, and we can see them real nice. Always pull out your highest term. The lead term for number 7 is negative x to the 5th. It's an odd, so it acts like a cubic that's been flipped upside down. So the left end goes up, right end goes down. Now we need to say it more mathematically correct. So the left is always x going to negative infinity. The right is always x going to positive infinity. That never changes. X goes to the left, negative infinity. X goes to the right, positive infinity. Mathematically speaking, the y value is going up on the left. So we just have to say that the y is going up to positive infinity. So this means left. That looks weird. This means left. This means up. And then on the right, we know the right is going down. So we have to say that the y is going to negative infinity. This means right. This means down. Okay. So left and right never change. Okay. Let's do number 9. The lead term is x to the 4th. It looks like this. Looks like a parabola pointing upward. So the left end is going up. The right end is going up. Both ends are going up. That's what that says. Both ends are going up. That's what that says. Last one for these odd ones. Lead term is negative x 5th. It looks just like, the ends look just like number 7. The left end's going up, the right end's going down. My cubic has been flipped. That's why we learn those parent functions. So as x goes to the left, negative infinity, my y is going up. That's what that means. As x goes to negative infinity, y is going to positive infinity. As the x's go to the left, the y's are going up. As x goes to the right, my y's are going up still. Oh, no, they're not. They're going down. They're going down to negative infinity. Sorry about that. So the lead term describes the end behavior because as we get very large, whether it's negatively or positively, the highest power wins. If you take 1,000,000 to the 5th power, all those little cubes and squares don't do diddly squat because those big numbers win at those large values to the left or right. Okay. Let's do the even ones. Our lead term for number 8 is 2x squared. That looks like a parabola pointing up. It is a parabola pointing up. As x goes to the left, that's to negative infinity. The y is going up. That's positive infinity. As the x goes to the right, the y is still going up to positive infinity. Let's do 10. Our lead term is negative x cubed. Looks like a parabola that's been flipped, a cubic that's been flipped upside down. I looked at the parabola and said the word parabola. Looks like a cubic that's been flipped upside down. As x goes to the left, my y is going up. As x goes to the right, my y is going down. Lastly, number 12 and number 8 are identical as far as their end behavior. The lead term of this is x squared, which looks like a parabola. It is a parabola. As we go to the left, our y's are going up. As we go to the right, our y's are still going up. So end behavior, don't get hung up on the notation. Left is always x going to negative infinity. Right is always x going to positive infinity. Those don't change. And then is your y going up or down? If it goes up, that's positive infinity. If it goes down, it's negative infinity. So don't get hung up on. This is very easy to determine. Just make sure you know the notation. Okay. And then don't worry about 13. I want to do 14. And we were going to do a little quiz, but I think we're going to do it at the beginning of class on Monday. Okay, but we're going to do the little review here in a second. Let's do 14. It says, write a polynomial function g with degree greater than 1 that passes through the points 0, 1, 1, 1, and 2, 1. Oh, we're going to skip that too. Actually, go back to 13. I don't care about 14, but I do want to do 13. Okay. If I want to write a polynomial whose zeros are 1, 2, and 3, the way that I always think of a polynomial I think of it like that there's some front coefficient that might have changed things, but it's really x minus the 0 times x minus the 0 times x minus the 0, however many of those I need. So I like that and knowing that, and I don't know if IMath asks questions like this, but it's kind of important to know it. They were doing it for the quadratics. I don't know if they do it any higher power things. But I know for sure that my zeros show up like that. There were 3 of them, 1 at 1, 1 at 2, and 1 at 3. It's always x minus the 0, x minus 0, and so on. My function is negative for all values of x. My function is negative for all values of x. I don't see how that's possible, but what we'll do is we'll throw a negative in front. And the degree, it would be higher than 1. This, I don't see how that's possible. Yeah. Okay, tell me. Because it would bounce, wouldn't it? Oh, I love that so much. Okay, because if we did it, it would keep bouncing off the x-axis. It would never get through it, and so it would all contain underneath it. I love that so much. Thank you. I was like, how in the world are they going to keep it all contained in one section? And that's perfect by bouncing it. So it could be 2s or 4s or 6s or 8s. Thank you for helping my brain. Okay, last little thing, quiz review. We will have a quiz on Monday at the beginning of class before notes. Okay, the quiz will look very much like what you see here. I will give you a function in factored form. So these aren't the kind that you have to factor. We're going to take it baby steps. I'm going to give you a function in factored form. You're going to tell me the zeros, the intercepts, the lead term in the ends, and then you're going to graph it. Okay? The zeros, the y-intercept, the lead term in the ends, and you're going to graph it. Okay? So the zeros, you're just going to set x minus 2 equal to 0 and x plus 1 equal to 0. You're going to factor it. Those are the zeros. So step 1 is done. The intercepts, those are the x-intercepts. I'll be more clear and tell you the y-intercepts. If you plug in 0, you actually get 4 times 1, or you get 4. Here our lead term, when it's in factored form, you have to pull out the x's and any powers on the outside, so and any coefficients. So x squared times x, or x cubed, which means the left end is going up and the right end is going down. I don't need the notation we used. If you give me the correct notation, like x is going to negative infinity and y is going up and so on and so on. If you give me the correct notation, I'll give you a bonus point. Okay. Now let's graph it. So here's -2, and here's -1, and here's 2. Okay. So we have zeros at 2 and -1. We have a y-intercept of 4. Our left end goes up, our right end goes down. We are going to have a bounce at 2, but we're going to go through -1. Does that sound right? A bounce at 2, we're going to go through -1. But I'm a little confused about my 4. Let's see. Do I get 4? If you plug in 0, I get -2 squared times 1. So I have to go through this. No, stop. Okay. Guys, do my ends go the way I just said my ends go? I'm sorry. How about if it's a positive, the left end goes down and the right end goes up? So sometimes your mistake will reveal itself because there's no way for that to possibly happen. So our left end has to go down and our right end has to go up, which means we would come up to this point, through there, and then bounce. There we go. I'm like, what has happened? What did I do? So sometimes the pieces and parts won't fit together. Expect on Monday at the very beginning of class a very quick quiz. I'll give you a function like this. You will do just like what we just did. Okay. And hopefully you won't make that mistake that I did. So turn this in, please. You don't have a lot of time, but you have a little bit of time. Go ahead and open up your iMath. You do have some homeworks due on Sunday. So there you go.